Today we're going to continue looking at section 5.3. So our objectives, we're going to identify the pairs of angles formed by a transversal cutting parallel lines, and then we're going to apply theorems about parallel lines. So let's take a look at this diagram. And once again, we are given different situations and we want to figure out what the measure of an angle is, and we're going to state why we know that. So in this first problem, we are given that line A is parallel to line B. So if I highlight that, parallel once again means that those two lines will never intersect. We're talking about angle 24. So angle 24 is right here. We're also talking about angle 22, which is right here. So hopefully we're okay with noticing that the transversal is going to be line Y. That's what's helping form angle 24 and 22. So now I just need to figure out what kind of angles are these. So based off the transversal being line Y, I see that both of these are below the transversal. So they're on the same side. I noticed that with my parallel lines, 24 is outside of it while 22 is inside. So if they are the same side, but one's inside and one is outside, then we're talking about corresponding angles. And so remember, when we have parallel lines, corresponding angles are congruent. So since angle 24 is 34 degrees, so is angle 22. So once again, our justification, we start with parallel lines because we're told that A and B are parallel. And once we know that, we figured out that these were corresponding angles. And so with parallel lines, corresponding angles are congruent. Okay, let's take a look at this next example. So I'm going to get rid of that. We are talking about X and Y being parallel lines. So I'm going to highlight those two lines. These two lines will not intersect. I am talking about angle 7. Angle 7 is located right here. We're also talking about angle 18, which is located right here. Notice that these two angles are being formed by this third line, which is C. So that's my transversal. So if I look at my angles, I see that 7 and 18 are both to the right of that transversal. So they're on the same side. Both of those angles are inside of my parallel lines. So when we're dealing with same side interior angles, we're talking about supplementary angles. So since I was given a 97-degree angle, I'm going to subtract that from 180 because that's what it means to be supplementary. And so we have an 83-degree angle. And why do we know that? Well, we started with parallel lines. And from there, we identified that we have same side interior angles, which then we know based off of our theorem are supplementary. So there's my justification. All right, let's take a look at this. It says find the measure of the angle indicated in bold. And so our bold angle right here. So notice that in this picture, I have the markings that indicate we're dealing with parallel lines. So when I have parallel lines, I either have congruent angles or supplementary angles. Looking at these two expressions, I see that these two expressions are inside of the parallel line, so they're interior. I see that they are on opposite sides of the transversal. So don't forget, when we have parallel lines and I'm dealing with alternate interior angles, I know based off of my theorem that that means that those are congruent angles. So that means I'm going to set up an equation where 16x minus 3 is going to equal 14x plus 13. Now I want to start solving for x. So I'm going to subtract 14x from both sides. That gives me 2x minus 3 to equal 13. I'll add 3 to both sides. That gives me 2x now equals oops, that's 16. And then I'm going to divide by 2. So it looks like I got x to be 8. However, remember that's not my final answer. I want the angle that is bolded. So I'm going to take 14, multiply that by 8, and then add 13 on to get my measure. So 14 times 8 is 112. And when I add 13 onto it, looks like we have an 125-degree angle. All right, let's take a look at this. We are told that A is parallel to B. We want to find x, y, and the measure of angle 1. So if A is parallel to B, I can mark that in my picture. Those two lines will never intersect. Notice that we have a transversal. Because I see some expressions with both x and y, we could potentially have to set up a system. Notice, though, that I see this expression with an x, and I see this expression with an x, and I notice that they are both on the same side of the transversal because my transversal is line C, and they're both above it. I noticed that 3x plus 30 is inside of the parallel lines, while 9x plus 6 is outside. So if we think back to our different theorems, when I have parallel lines, those are corresponding angles. And don't forget, corresponding angles, those are congruent. So I actually can solve for x without having to set up a system because I can take 3x plus 30 and set that equal to 9x plus 6. So to solve for x, I'm going to subtract the 3 from both sides. That gives me now 30 to equal 6x plus 6. I'm going to subtract 6 from both sides. That gives me 24 to equal 6x. And so then I'm dividing both sides by 6. And we get our first answer. 24 divided by 6 is 4. All right, now we need to solve for y. Well, I only see one expression that has a y. I notice that it has a relationship with this 9x plus 6 angle because they share a vertex and they're directly across from each other. And so that tells me that we have vertical angles, and vertical angles are congruent. So I know that 7y is going to equal 9x plus 6. Now, because there's two variables here, I would have to set up a second equation. However, I already know what x is based off of us solving for x already. So if x is 4, I'm just going to substitute that number in, and then there's no need to create a second equation. So 9 times 4 is going to give us 36. If I add 6 onto it, I know that 7y is going to equal 42. And then I'll divide both sides by 7, and that gives me a value of y to be 6. The last thing that we need to do is we need to solve for the measure of angle 1. So we're looking at the fact that angle 1 doesn't have an expression listed, so I can't use my x and my y to substitute something in. But if I look at these two angles, there's a relationship there. They are right next to each other and they're forming a straight angle. So I know that those two are supplementary. So if I figure out what the measure of 3x plus 30, if I find out what that is, all I'm going to have to do is subtract that from 180, and I've got the measure that I'm really looking for. So let's do that. I'm going to take 3 times 4 plus 30. And so that tells me that 12 plus 30, I have a 42-degree angle there. And so the measure of angle 1 is us taking 42 away from 180. So 180 minus 42 tells us that the measure of angle 1 is an 138-degree angle. So that's us identifying pairs of angles formed by transversal cutting parallel lines and then applying theorems about parallel lines.